In today's video, I will going to demonstrate you multiple linear regression. So basically, it's extension of simple linear regression. In multiple linear regression, we basically use more than one independent variable in order to predict our dependent variable y. So it's simple as that. So in basically in simple linear regression, we tries to find a fit line to our data set. However, in multiple linear regression, we basically find a hyperplane for our data. All right. Okay, so let's jump into it. So we imported our modules, then we imported our data set. So here we can see that we have columns. So we have CO2 emissions and we are going to predict this. So in this case, we have a Y, CO2 emissions, and we can take several independent variables. Maybe fuel consumption, fuel type, or maybe cylinders, which we will take those independent variables which has an impact on dependent variable. So please keep in mind, all right? So we will only take those which has linear, what do you say, linear relationship with y dependent variable. All right. So here I took all of those columns already, which has effect on dependent variable. All right. And in this case, we have a dependent variable CO2 emission. So here we can see our data. And then I drew a scatter plot. Here I plotted engine size on x-axis, and on y-axis we have CO2 emission. All right, so we can see that it has a pure linear relationship. So it's mean that when we will have an increase in engine size, it will lead to increase in our emission, CO2 emission. All right. Okay, so let's move on to onward, and here I'm taking the training set 80%. We can say 0.8. So I'm taking 80% training set, and testing set I'm taking 2-3% testing set. All right. So here we basically did a train test split. Now there is a function we can use, but for now I did something like this. So now let's plot again, and here I'm going to plot using our training data set and training data set for the y-axis column 2. All right, so we can see that we have a linear relationship. All right, so now go ahead and train our model. So here from scikit-learn I imported linear model, and I instantiate our estimator here, and then I am going to take our x, which basically our three independent variables, and then we have a y, CO2 emission. All right, and here we are basically training our model. So here we are training our model, so we can see the coefficients of our model here. So basically there's a formula. We can see like y hat is equal to, so let's make this as a comment, y hat is equal to what do you say, theta 0, which is basically an intercept. Then we have theta 1, and here we will have a feature 1, x1. Basically x1 is a feature independent variable. So basically now we have three independent variables, so we will have a 3x. Let's grab this here and insert this here, 3x. All right, so x1, x2, theta 2, and here we have x3, theta 3. So we have three independent variables, so we can see that we have three x's here. All right, so this is a feature 1, feature 2, and feature 3. And for example, if we have 4 or maybe 7, so here we will extend to that. All right, I hope it's clear. And this is, in our case, this is intercept. All right, and basically we will at the end, after finding our coefficients and what you say intercepts, we will simply plug that values in this equation, and we will simply find our dependent variable, which is in this case CO2 emission. All right, so here we can say, so basically we are training our model here, and I'm saying here is that for every independent variable we have CO2 emission this and this. So here this is how I am training our model. All right, so here we can simply predict. All right, so here from the testing data set I simply put here what you say, the dependent variables, sorry, independent variables, all right. And I am giving these as the independent variables in order to predict. And then what I'm doing is I am taking x and y for our testing data set, all right. So we have, what do you say, we have independent variables, and these is actual values, this is our actual values, all right. So here I find it out the mean. All right. So basically, how we this is basically mean squared error. All right. We are finding here mean squared error, and basically what we do here is basically here basically the y hat contains the predictions that made from our model. So all right. So basically we gave the data, and it did predictions here. So basically, how we will calculate the errors here? Basically, we will calculate it by subtracting this y hat with our actual values, and actual values are the real values, all right. So we will first of all subtract these, and then we will take a squared, all right, squared of these errors, and then at the end we will take the mean. So this is how we can take mean squared error, right. I hope this is clear. And then we can also find the variance score. um, Here we can see that there is a function. So basically this is a function from our model estimator object, and we can basically do score, and we can give our x and y data set basically, and this is from our test data set, just keep in mind, all right. And if the value is nearer to 1, so it's mean that the our model is more accurate and optimized. Otherwise it's mean that it's not optimized. So this was multiple linear regression. I hope you understand this. This is as simple as simple linear regression. If you didn't watch my simple linear regression video, I suggest you to watch that video first. And if you watch that video first and then you come to this video, this video would be easier for you to understand. I hope you learn from this. And if you learn from this, just subscribe to this channel and hit the like button and do comment. And I would love to hear suggestions from you guys. Thank you so much. Bye bye.